In this video, I will talk about aqueous solutions and precipitation reactions. First, let's define electrolytes and non-electrolytes. Electrolytes are substances that dissolve into ions when dissolved in a solvent. In this case, we will use water as the solvent, and electrolytes conduct electricity by ion migration. We have two types of electrolytes. One is strong electrolytes, which dissociate completely when dissolved in solvent. For example, hydrochloric acid is a strong acid, sodium hydroxide a strong base, and potassium chloride a salt. When these are put with water in a solution, these become strong electrolytes because their ions dissociate completely. And notice that they have the state AQ for aqueous solution with water. And if we put one of these solutions with two plates connected with a wire and a light bulb, and we run a current between the plates, this solution will be able to conduct electricity because we have ions throughout the solution that are able to carry electrons from one plate to the other. So the light bulb is the most lit up. Second, we have weak electrolytes, which dissociate partially when dissolved in solvent. For example, acetic acid can give up the hydrogen in its molecule and be given to water to form hydronium ions. But in a solution, only a portion of these acetic acid molecules dissociate. So we have a partial dissociation that forms a weak electrolyte. And when we run the same experiment as before, and we run a current between the plates, the conduction will not be as effective as the one with the strong electrolytes, so the light bulb will be dimmer than before. Then we have non-electrolytes, which are substances that may dissolve in solvent but do not dissociate into ions. Therefore, they do not conduct electricity. For example, we have ethanol. So this one is an organic molecular compound that has covalent bonds. The majority of non-electrolytes are of this kind, organic molecules. So if we run the same experiment of ethanol in water and we run current between the plates, there won't be any conduction of electricity between the plates because the ethanol does not dissociate in water. The substances that we just reviewed are soluble in water, so they form a homogeneous solution. But there is also substances that are insoluble in water or any other solvent that do not dissociate and also do not form homogeneous solutions. So let's define both of these. Soluble substances are the ones that dissolve to a significant extent in a specified solvent. They can be grouped into two. One is molecular compounds, which for the most part are organic compounds that do not dissociate in water. For example, if we have sugar in water and we mix them together, we form a homogeneous solution of sugar and water. The equation that represents this is solid sugar or sucrose molecules that, when mixing with water, form an aqueous solution of sucrose. So there is no ion dissociation. Therefore, this is non-conductive, just like in the case of ethanol. The second group is ionic compounds, which dissolve by dissociation. For example, if we have potassium dichromate and we put it interacting with water and we mix them together, there is ion dissociation into potassium ions and chromate ions. So in this figure, we can see that we start with the solid potassium dichromate, we mix it in water and we stir, and we form a homogeneous solution that is red. So in both cases, we form homogeneous solution, and that's representative of a soluble substance. Then we have insoluble substances, which are the ones that do not dissolve significantly in a specified solvent. For example, if we have a powder of chalk and we put it in water, so chalk is calcium carbonate. After mixing, we will see that we form a solution that is white, but over time, the chalk will just sit at the bottom of the water. So this is a heterogeneous solution. And the calcium carbonate or chalk does not dissolve in water. So this is an insoluble substance. To know whether a substance will be soluble or insoluble in water, there is a set of rules that are used to predict that. The rules are summarized in this table. So, not all ionic compounds dissolve in water. And a list of solubility rules is used to decide what combination of ions will dissolve or precipitate. A problem that we will encounter in this chapter is that of mixture of two solutions that are aqueous and they contain soluble salts, and when they mix together, sometimes an insoluble salt or a precipitate will be produced. Let's go over one example, and let's use this table to predict and make sure that we're getting the right precipitate. So if we mix a solution of silver nitrate with a solution of sodium chloride, the result will be that we form a solid precipitate of silver chloride, and this is in an aqueous solution of sodium nitrate. So if we go over the ions that will be produced upon mixing, it's this. And we see that silver and chloride are the ones that form the precipitate. So we crisscross the cations and the anions. And the sodium and nitrate ions are the ones that remain in solution. So here's a picture of what's going on. So we have a solution of sodium chloride, and then we have the silver nitrate being dropped inside, and this white precipitate is the silver chloride being formed. Finally, let's check with the table to see whether it predicts the solubility or insolubility of the compounds at hand. So silver nitrate, we can see here that nitrates and acetates are soluble compounds. So this should be aqueous or soluble. Sodium chloride, we see here that chlorides are soluble compounds. Then we have silver chloride, and we see that chlorides are soluble, but there is exceptions, and silver is included, as well as mercury and lead. So this is solid, precipitate, or insoluble, because it's an exception of chlorides. Finally, we have sodium nitrate, and we see that nitrates again are soluble with no exceptions. When we mix two aqueous solutions and we have the formation of a precipitate, we can write net ionic equations that focus on the precipitation reaction. So let's go over 4 steps that you must know to write these net ionic equations using the example that we saw before, the one of mixing silver nitrate aqueous solution with sodium chloride aqueous solution and forming silver chloride precipitate. So first we balance a molecular equation. So to make sure that this is balanced, we count the number of atoms on each side. We have 1 silver, 1 nitrogen, 3 oxygens, 1 sodium, and 1 chlorine on the left hand side. On the right hand side we have 1 silver, 1 chlorine, 1 sodium, 1 nitrogen, and 3 oxygens. So this seems to be balanced. The second step is to dissociate all strong electrolytes. So on the left hand side we dissociate the two aqueous solutions into silver ions, nitrate ions, sodium ions, and chloride ions. All of these are in aqueous solution. Then on the right hand side we have the precipitate form, and we do not dissociate that one. We have silver chloride in solid form, and also the aqueous solution of sodium ions and nitrate ions. The third step is to cross out anything that remains unchanged from the left side to the right side of the equation. So we cross out the nitrate on both sides, the sodium ions on both sides. And finally, we write the net ionic equation with the species that remain. This is the precipitation reaction. So the species that remain on the left are the silver ion, the chloride ion, and these are all in aqueous solution, and the right hand side is the precipitate, the silver chloride. So this is the balanced net ionic equation.